good morning, good evening, whoever watching at what time. So take whatever you want, right? So welcome to Unacademy, India's largest online learning platform, which is helping the students of all corners of India from all walks of life. From all walks of life, you may consider engineering, you may consider medical, you may consider intermediate, whatever there. Unacademy is with you. Unacademy is with you. So this is a crash course on analog electronics. Crash course on analog electronics. So which is planned from Monday to Saturday. This is planned from Monday to Saturday by myself, Shravan Kumar. By myself, Shravan Kumar. So before moving into the other topic, I wish you all a happy Pongal. So this Pongal may bring a lot of happiness and prosperity in your life, right? Today is a very good festival. So we call it as the Makara Sankramanam. That is, the sun is moving from Dakshinayam to Uttarayanam. So which is actually very auspicious. Which is very auspicious for all of us. So hope this 2021 will bring more happiness. We struggled through 2020. We are warriors. We lived successfully in this pandemic time. We faced many challenges in life, but still we are able to survive. And thanks to the God, the Almighty God, so who helped all of us by giving a lot of strength, and every human being who helped others in this pandemic time. That is the greatness of our country, India. That's the greatness of our country, India. Right? I wish you all a happy Pongal again. I wish you all a happy Pongal again. So we'll hope we'll celebrate this Pongal very happily. Right? So we'll move on. Now, so this is a course is called Analog Electronics course. So which is a crash course. So now we are talking about the BJT, the third part of the BJT. So this Analog Electronics course will help the students of electronics and communication engineering students, electronics and electrical students and instrumentation students who are preparing for GATE and ESE. GATE and ESE. Okay. So myself Shravan Kumar, most of you already know, but it's my duty to repeat. So myself Shravan Kumar, having master's degree from JNTH in Wireless System Design. I have 10 plus years of teaching experience. And subjects I can take is EDC, analog electronics, digital electronics, and EMFT. I'm targeting this EDC and analog electronics for 2021, and these two for next year, 2022 and 2023. So I'll try to finish these two subjects before January 31st, Jan 31st, so that the students who are attending the GATE examination, I think GATE hall tickets are also out. You know right now where you are doing. I mean where you are going to write the exam also, right? I wish you all the best for all of you. And I have a special code for all of you, that is SPS 10. So SPS 10 is a special code to get 10% off on Unacademy plus subscription. So what you mean by plus subscription is, a plus subscription is you will be able to access all the live classes, crash courses, weekly tests. Weekly test is very important, as time and again I'm mentioning. To measure your progress, you should know what is a weekly test. Writing weekly test, you understand where you are. Right. So after writing the weekly test, you can also interact with the faculty. You will have a beautifully direct interaction with the faculty, which will give you a doubt solving sessions. Every 4th hour is going to be a doubt solving session, and sessions will be luckily in English and Hindi. They are luckily in English and Hindi. Those who are unable to understand Hindi, they can listen in English. Those who are unable to understand English, they can listen in Hindi. Right? And you have something called rank improvement batch, so which is very important. What do you mean by rank improvement batch is, those students who are having very strong foundation in theoretically, and they want to increase their rank. This plus subscription is very, very important. So along with this plus subscription, we have another plus subscription called iconic subscription. So what do you mean by iconic subscription is, along with all the benefits of the plus subscription, you will be also having something called a personal coach who will guide you in preparation strategy. So how to prepare for the exam, that everything will be guided, right? And you'll have something called a study planner. You'll have something called study planner, and you'll have a study booster session. You'll have a study booster sessions, and we'll have a personalized test analysis. So the in-depth analysis will be given for everyone on the test which you have taken, section wise and question type. So where you are lagging, how to prepare, all these things will be helpful after doing this test analysis. Now, and finally, what we have is a very important that is called specialized notes and practice sets will be available. Specialized notes and practice sets will be available. This is very, very important. Now, for a plus subscription, you will have it 12 months, 18 months, and 24 months. For 12 months, this amount is going to be 27,225 rupees. For 18 months, it's going to be 34,650 rupees. For 24 months, it's going to be 13,600 rupees. And the code is going to be SBS10. For all the three, you use this code to get 10% discount. 10% discount, which is actually cheap, sir. Which is actually very cheap. And then I have another subscription called 12-month subscription, 24-month subscription. In case of 12-month subscription, the fee is going to be 45,225 rupees, and for 24 months it's going to be 66,600 rupees. 66,600 rupees, and you have again a code called SVS10. SVS10 to get 10% discount. So how to get this is that simply by just download an Unacademy app. And install the app in your mobile phones. And step 4 is going to be, so manage your goal. So as I told you, we are spread in our wings are spread into many areas. That is NET, GATE, NEET, PG. All these things are there. So you should choose GATE and DST as your goal, and once you choose the goal, you will be taken to another step called selection of plus. So once you click on plus, so you will be given an option to get subscription. So once you click on get subscription, what happens is you will be taken to another window which where you have to choose 12 months or 24 months. So once you choose 24 months, you will be asked to type a code. So don't forget to type this SVS10. SVS10 is a super code for all of you, right? Use this super code, that SVS10, and click on apply. Then you will be taken to the last step, step 7. So where you have to pay the amount. So you can use a debit card, EMIs, UPIs, wallets, and net banking. So whatever you want, you can use this. And you can simply pay the amount. Okay. Now I request all of you to follow me on Unacademy. So this is my code. Most of you know it, but I am trying to repeat it again so that somebody who is listening for the first time, so they can understand. And don't miss to follow me. Because very, very important, sir. If you follow me, all updates you will get from my side. Right? So whatever I'm teaching, where I'm teaching, everything will be available. Okay. Now, so before going to this, I think this is the previous problem which we are supposed to discuss. This is where I missed. So I'll go back and see from the last discussion. So I think we have discussed different types of, in the previous discussion, we have a transistor has 2 PN junctions that we have discussed. Different regions of operation, and we have seen what type of operations we have, and what are the applications of that, what is the region, what is the applications of that, what are the different conditions also we have seen. And we have seen of the transistor can be operated, it can be used as an amplifier or switch. And we have also seen what are the configurations, right? Different configurations which we have seen. I think we have also seen this. We have also calculated the value based on the requirement, and we have also what is the mode of operation we have also discussed. I think this is the problem which we are supposed to discuss, right? So we'll try to finish off the problem here itself, so that we'll go back to the today's discussion after finishing this problem. Okay. Okay. Now see what it's saying, sir. The following circuit has a beta value. He has given beta. Beta is 30. Okay. The reverse saturation current IC B naught is going to be 20 nanoamps. Very happy. 20 nanoamps. Very happy. And the input voltage V in. V in is going to be 5 volts. V in is going to be 5 volts. And then he's asking find the mode of operation. Find the mode of operation. So to find the mode of operation, so first we should know how can you say find the mode of operation means you should find out how the emitter base junction is there, either emitter base junction is forward bias or reverse bias, and then collector base junction. So generally we represent with the JE, and this is going to be JC. Now, if we are able to find out what these two emitter and collector junctions are doing, then we can easily say which mode of operation it is. So now we can see here, it looks a bit difficult to do it. So simply what we'll do, sir, for ease of calculation, we'll apply Thevenin's theorem till this point, so that it will be very easy for us to calculate something. So first let us try to apply, find out the voltage, so that voltage and resistance, after looking from this side, we will try to find out what is the Thevenin's equivalent. A Thevenin's equivalent we'll try to find out. Once we find out the Thevenin's equivalent for this, now we can easily calculate. The emitter base junction is whether forward bias or reverse bias. From that discussion, we can also calculate whether the collector base junction is reverse bias or forward bias. So then we can conclude that what is the mode of operation of the transistor. Okay. Okay. Now we will see a Thevenin's equivalent for this. So to find out the Thevenin's equivalent, so what is the remaining, sir? Simply it is 15K, and we have 5 volts here, and here we have a resistance, and we have another volt called 12 volt, minus 12 volts, 100K. So what we need to find out, sir? We need to find out V Thevenins and R Thevenins. And then R Thevenins. We need to find out. So R Thevenins is very easy. What is R Thevenins, sir? So from here to here, all these voltages must be grounded, and all voltages must be grounded. 15K and 100K will be in parallel. So R Thevenins is going to be what? 15K in parallel with 100K. So what do you mean parallel, sir? You multiply them on the denominator, on the numerator. Multiply in the numerator and add in the denominator. Multiply. Remember, always very easy, sir. You have to multiply them. In the numerator and denominator. You should just add them. So this is going to be 15K plus 100K. So this is going to be 1500 K and K, and then it's going to be 115K. So this K will get cancelled. So 115 into 130, 115. So what I'm going to get is, can you please calculate, somebody can calculate, I think, or otherwise I have the answer. So R Thevenin is going to be 13.04 kilo ohms. So once I'm able to calculate the value of R Thevenins, now I'll try to calculate the value of V Thevenins. So how we will calculate V Thevenins, sir? Simply understand it's going to be, remember, it's going to be equal V Thevenin's voltage. So V Thevenin's voltage. Now to calculate V Thevenin's voltage, it is very easy now. Right? So how will you calculate the V Thevenin, sir? How will you calculate the V Thevenin's value? So V Thevenin's value can be calculated very easily. That is V Thevenin's minus 5 by 15K plus V Thevenin's minus 12 by 100K is equal to 0. This is also K. K will anyway K will get cancelled. So what you are going to have is V Thevenins by 15 minus 1 by 3. I'll directly writing this. So plus V Thevenins by 100 plus 12 by 100 is equal to 0. So now calculate what is this, sir? So from this you need to calculate V Thevenins. Can you please calculate V Thevenins? Calculate VThevenins. So if you calculate VThevenins, what you are going to get is, I'll just simply write here. So VThevenins is directly going to be 2.78 volts. 2.78 volts. So VThevenins is 2.78 and RThevenins is going to be 13.04 kilo ohms. 13.04 kilo ohms. So now I'll try to redraw the circuit. If we try to redraw the circuit, it looks like this. It's going to be RThevenins. It's going to be VThevenins. And then so you have a circuit like this. So do we have RE resistance or not? Yeah, we don't have RE resistance. No issue. No issue, sir. No issue. This voltage is how much he has given? 12 volts, 22K. Sorry, 12 volts and 22K. 22K. So this is going to be VThevenins. So how much is VThevenins we got, sir? 2.78. The RThevenins is going to be how much, sir? RThevenins is how much we got? 13.07, 13.04, 13.04, 13.04 ohms, kilo ohms, sorry, 13.04 kilo ohms. So now he has given beta value. Anyway, beta is positive, so beta is going to be 30. He has given, and he's also given ICB naught, ICB naught, ICB naught. So ICB naught. So what is the formula for? What is the formula for this? Now you can see here. So this is 0 volts. This is 0 volts. When this is 0 volts and you will be having some positive voltage here or not, let's say RThevenin's drop is very small. RThevenin's drop is very small. What you're going to have is going to be 2.78, almost 2.7 volts here. You're going to have 0.7 is 2.7 minus 0.7 almost going to be 2 volts. Actually means it is 0 volts and 2. So what happens to this emitter base junction? What happens to emitter? Base voltage VB is greater than VC. VB is greater than, sorry, VE. VB is greater than VE means base emitter junction is forward bias. Junction is forward biased. So when base emitter junction is forward biased, now either you will have transistor in active region, or you have a transistor in saturation region. Saturation region. So there are only two chances: active or saturation. So active or saturation. Now assume that the transistor is in. Assume transistor is in. Transistor is in active region. Active region. So when the transistor is in active region, now simply what will assume, sir? The beta is equal to I. So now what you have to do, sir? Apply just KVL here. Apply KVL to the output loop. So what you'll get, sir? I mean, say here you first you'll try to know the value of IB. If you can able to calculate the value of IB, you can able to calculate the other values. So they'll assume that assume VBE is going to be, whenever now he has not given, assume it's going to be 0.7 volts. So apply KVL here, sir. 2.78 minus IB into 13.04 kilo ohms minus 0.7 is equal to 0. So what you'll get, sir? 2.08 is going to be IB into 13.04 K. So what is going to be IB? IB is going to be 2.08 by 13.04. So calculate this. You just calculate this. Please calculate this. So if you calculate this, what IB is going to get is, the IB value which you are going to get is 0.159 milliamps. 0.159 milliamps. 0.159 milliamps. Now, how to calculate the value of IC? IC is going to be how much? IC is going to be actually how much, sir? IC is going to be beta IB plus 1 plus beta into IC B naught. IC B naught. So beta is how much, sir? 30 into how much is going to be IB? 0.159 milliamps. Plus 1 plus 30 into how much IC B naught? IC B naught is how much? IC B naught is 20 nanoamperes. 20 nanoamperes. 20 nanoamperes. Sir, if you can see this in milliamps, it's going to be in nanoamps, which is very less. So this can be neglected. This can be neglected. So what IC you are going to get? IC simply you are going to get is 30 into 0.159. So you are going to get 4.77 milliamps is the IC value. 4.77 is the IC value. So when you get the IC value, now what you have to do, sir? Once you get the IC value, you have to just find out the value of VC. So how to calculate the value of VC, sir? Now how to calculate the value of this VC? To calculate the value is very easy, right? So 12 minus ICRC minus VC is going to be that. The formula is VCC minus ICRC minus VC is equal to 0. So what you need, sir? VC. VC is going to be VCC minus, ICRC. So what is VCC? You have 12 volts. What is IC, sir? You got just now we got 4.77 into 10 to the power of minus 3. So what is then this RC? What is the value of RC as given? RC value is going to be 22K. 22K. So when this is going to be 22K, 12 minus, so 22K into 4.77. So it's going to be 104.94. Sir, I know because I have already calculated. I am writing this. I know I have already calculated this because of I am writing directly. Right. So what you get is minus 92.44. 92.44 means VC is negative. VC is negative. So what we know, sir, when VC is negative, means what? VC is less than 0.2 volts. It is VC is less than 0.2 volts. Means it is collector emitter junction is collector base junction. Collector base junction is collector base junction is forward biased. Okay, this is also forward biased. So now already we know that emitter base junction is forward biased, and here also collector base junction is also forward biased. So the transistor is in which mode of operation, sir? Saturation. The transistor is in the mode of saturation. Are you getting the point or not? They're very simple. Don't think that these are difficult. Very simple problems. Simple problems, all these things. Only thing is you need to know just KVL. If you know just KVL, you will be able to solve the problem. Right? You should practice KVL, sir. You should definitely practice KVL and KCL. 90% of the problems in analog electronics will be solved by only KVL. So we don't need much formulas to remember. Okay, so this is about the previous problem. Now coming to today's topic. So this we have already finished. So now we will talk about something called small signal amplifiers. So I think I have already told you about in the previous class what do you mean by small signal. The voltage which are less than VT value. Is called as small signals. Then what is an amplifier? What do you mean by small signal amplifier? What do you mean by actually an amplification? So the basic function of amplifier is to do a faithful amplification. So we said faithful amplification. What is that? Amplification means the process of rising the strength of a weak signal without any change in its shape is known as faithful amplification. So this is very important. The major purpose of the amplifier has to amplify the signal or strengthen the weak signal. Strengthen the weak signal. It means, let's say your V input is going to be 1 millivolt. 1 millivolt. Actually, even 1 millivolt is also not correct. So what you need to do, sir? V output should be at least 100 millivolts. 100 millivolts. So what it is doing, sir, is trying to strengthen the signal. Strengthen. It is adding the voltage. So V output is going to be 100 millivolts. So now, and without changing shape. So let's say input is sine wave. Output should also be a sine wave, sir. Output will also be a sine wave. Output is also sine wave. Let's say input is a sine wave, output is a triangular. No, this is not an output. That is not a faithful amplification. Faithful amplification is something which will be same as that of the input. The shape of the input should not be altered. Without altering the shape of the input waveform, the signal has to be amplified. The signal has to be amplified. So remember this point very clearly. Remember this point very clearly, which is very important. Now you can see here, this is a common emitter amplifier. Generally, we call this as which biasing, sir? This is which biasing is called? This is voltage divider bias, sir. Voltage divider biasing. Sir, as it is a crash course, I am unable to discuss complete biasing methods. We have different biasing methods. So out of which we are unable to discuss all those biasing methods here. Just a second. Sorry. So we are unable to discuss. All those biasing methods here. But it is, remember, this is a voltage. What do you mean voltage divided bias? You can see the biasing voltage, the base voltage, the BC voltage, the VP voltage is because of the voltage divided between RB1 and RB2. Because of that reason, it is called as voltage divider. The voltage VCC is divided in between the resistance RB1 and RB2, and the voltage across the RB2 is responsible to turn whether the transistor is acting in an active region, saturation region, or in cutoff region. Okay. So the major important thing here is we should know what you mean by voltage divider circuit. You can see here. So you have a source resistance V input. You have a input capacitance. You have collector capacitance or output capacitance, we say. So we have something called CE, which is called a bypass capacitor. So why this is called bypass capacitor is in some cases what happens is, remember why, just the point I'm trying to mention here is why it's called a bypass capacitor is, this is called bypass capacitor because in some point of time, what happens is there will be fluctuations in the voltage. When there is a fluctuations in the voltage, all those fluctuations as capacitor allows sudden changes of the voltages. That is, all the AC is passed through this. So for all sudden changes of the voltages, this capacitor acts as short circuit. When this is short circuit, and in parallel you have a resistor RE, right? So whenever you see here, so this is a resistor in parallel with the short circuit. If short circuit, always the current chooses the low resistive path, right? When this is no resistance, here you have resistance. So for all the fluctuations which are occurring because of some reasons will be passed through the capacitor, CE. So because of that, we call this as a bypass capacitor, which is very important. You may ask some questions, or the examiner may ask. I'm sorry. The examiner may ask some questions also. On this point. Okay. So RE and CE. So CE is a bypass capacitor and CS is input capacitance and these capacitors CC also called as output capacitance. So the function of these two capacitors, as this is called bypass capacitor, these two capacitors are called blocking capacitors. Blocking capacitors. So what do you mean by blocking capacitors, sir? So it blocks DC. It blocks DC. So what is the need for blocking this DC, sir? If you don't block the DC voltage, if you don't block the DC voltage which is coming from the signal, so what happens, sir? The operating point of this, the operating point of the transistor will be altered. The operating point of the transistor will be altered because of that reason. Because of that reason, these capacitors CS and CC, CS and CC are CS and CC are called blocking capacitors. So why this capacitors? The DC voltage which is generated in this may disturb the operating point of the next. If you are using a multi-stage, let's say you are using a multi-stage. So what happens, sir? Here, now this capacitor should block the DC signal. If it is not blocking DC signal, now there may be a chance that the this will be disturbed. That is, next stage of the amplifier will be disturbed. Let's say you may have the same amplifier circuit again in a multi-stage. What happens, sir? You'll have different types of configurations connected back to back, So in that point, what happens, sir? The operating point of the next transistor circuit may be disturbed if I don't use this. So because of that, these two capacitors are called blocking capacitors. Blocking capacitor, and this capacitor is called, what is capacitor? This capacitor is called bypass capacitor, and this circuit of RB1, RC, RB2, and RE, and the transistor Q is amplifier circuit. Is an amplifier circuit. And the RS represent the input source resistance, and the V input is a V input. VI is a V input. The RL is the load resistance. So you may have different loads. You may have a sound system. Generally, public address system will use, because the major important application of this amplifier is public address system, or a speaker. Generally, we call the speaker. Generally, we call speaker. In general, we call. Okay. So now, sir. So in small signal analysis, or small signal amplifier, most important topic is this. Most important topic is this. What is that, sir? H parameter model. H parameter model. Sir, why this H parameter model is very important? Why this H parameter model is very important is, sir, in case of a normal PN junction diode, also we have seen the equivalent models. So the circuit model of a diode we have discussed here. This H parameter model is also nothing but the circuit model of a transistor, right? Circuit model of a transistor, right? So this is very important. If you are able to understand this, your analysis will be very easy. Your analysis will be very easy. Very easy. Now what is H parameter model? What is H parameter model? We also call it a hybrid parameters. We also call it H stands for hybrid. H stands for hybrid. Why it is called H hybrid, sir? Why it is called hybrid is, so in general, it is because hybrid is because it has a Z parameters and Y parameters, and voltage ratio and current ratio all are used to represent the relation between the voltage and current. Right? In two-port network, what happens? Remember now, in two-port network, different. So if all the voltages are expressed as a functions of currents, let's say V1, V2, in terms of I1, I2, that will be Z parameters. If I1, I2 in terms of V1, V2 is Y parameters. Now, but here, input voltage and output currents are expressed as a functions of input current and output voltage. Input current and output voltage. So because of that, they are called hybrid. It's called hybrid, and the parameters H11, H12, H21, H22 are also hybrid in nature. All of them don't have same kind of units. If you go and see, in case of Z parameters, all the parameters will have same units. All the parameters have same units. Very simple, sir. So what I told you, Z parameters. What happens, sir? V1 is a function of Z11 I1 plus Z12 I2, and V2 is going to be Z21 I1 plus Z22 I2. Z22. So what is Z11, sir? Z11 is equal to V1 by I1 with I2 is equal to 0. What are the units are V by I? V by I. Simply it is going to be ohms. So what is Z12? It's going to be, what is Z12? It's going to be V1 by I2. V1 by I2 with I1 is equal to 0. I1 is equal to 0. So what are the units again? V by I is going to be ohms. So similarly, in Y parameters, what happens, sir? I'll express all the currents in terms of voltages. All the currents, input and output currents in terms of input and output voltages. So they are called Y parameters. So Y parameters. But here, so one input voltage and output current, expressed as functions of input current and output voltage. Input current and output voltage. So this point is very important. This point is very important. This point is very important. So V1 is equal to H11 I1 plus H12 V2. So V2 is equal to H21 I1 plus H22 V2. So if you want to express this in matrix form, so V1 by I2 is going to be H11 H12 H21 H22 into I1 V2. I think you know how to multiply the matrix. I think you know. I don't need to explain here. I don't need to explain here how they are functioning. How they are functioning. Okay. Now. So if the input current I1 and the output voltage V2 are taken as independent variables, and V1 and I2 can be written as. So what is saying, sir? He's saying input current and output voltage are independent. Then input voltage and output currents are dependent. So this input voltage is dependent on input current as well as output voltage. Output current is also dependent on input current and output voltage. So then these equations will come. So now simply what happens, sir? H11. So what is H11, sir? The four hybrid parameters H11, H12, H21, H22 are defined as follows. So you can simply H11 is going to be V1 by I1, yes or no? V1 by I1 with V2 is equal to 0. When V2 is equal to 0, now what happens, sir? Very simple. If you make V2 is equal to 0, you make V2 is equal to 0, simply what happens, sir? You will get V1 is equal to H11 I1 plus 0. So from this H11 is what is this, sir? V1 by I1. V1 by I1. What is V? V is input voltage. What is I? Input current. So input voltage by input current. Input voltage by input current. Simply it is going to be input impedance. Input impedance with output short circuited. Why it is short circuited, sir? Because we are saying output voltage is 0. Output voltage is 0. Output voltage is 0. Okay. Now H22, what is H22, sir? H22 is going to be I2 by V2. I2 by V2 with I1 is equal to 0. I2 by V2 with I1 is equal to 0. Means it's I2 by V2 means earlier V by I is impedance. So now it is reverse. I2 by V2. I2 is what? Output current by output voltage. Output current by output voltage is what? I can call it as a admittance. Admittance with input current I1 is equal to 0. With input current I1 is equal to 0. So H22 is going to be output admittance with the input port open circuited. Why it is open circuited, sir? Because the current I is going to be 0. When can be a current 0? If the short circuit current 0, no. When it is open circuit only, current will be 0. So short circuit means voltage drop is 0. Voltage drop is 0. So this is called output admittance. This is called output admittance. Output admittance. Now, what is H12? H12, you can see here H12 is the ratio of V1 by V2. Input voltage by output voltage. Input voltage by output voltage. He is saying with input current I1 is equal to 0. With input current I1 is equal to 0. So what it is saying, sir? It is called a reverse voltage transfer ratio. What is voltage transfer ratio means? Output voltage by input voltage. But here what is there, sir? Input voltage by output voltage is there. Because of that it's called transfer ratio. Which is called transfer ratio. Sir, what are the units for this? This is going to be ohms. This is going to be mhos. Now we'll see what are the units for this. So it's a transfer ratio, or I can simply call it a gain. Reverse voltage gain. I can also say reverse voltage gain. With input port open circuited means what are the units, sir? No units at all because it's a gain. No units at all. No units at all. Yes or no? Is there any units? No units. Absolutely no units. Absolutely no units. Then what is H21? H21 is going to be I2 by I1. H21 is going to be I2 by I1 with V2 is equal to 0. With V2 is equal to 0. So what does it mean by V2 is equal to 0 means output port short circuited. Output port short circuited. That is, now what will get, sir? I2 by I1. So output current by input current. So forward current gain. We will say forward current gain with output port short circuited. With output port short circuited. So what do you mean by forward current gain? What are the units, sir? Sir, again, no units. No units. So now because of this reason, it's called hybrid parameters. So if you go back and see, in case of Z parameters, all the units are ohms. In case of Z parameters, all the units are ohms. In Y parameters, all the units are mhos. All the units are mhos. But in case of this, in case of H parameters, the units are not same. So for one H parameter is going to be ohms. For other parameter, for other it's going to be mhos, and for the remaining two it's going to no units. So you don't have a. So this is a combination. It's a combination of having resistances, admittances, gains. So all these are combinations. So as all these are combinations of different parameters, so we call this as a hybrid parameters. We call this as a hybrid parameters. Is the point clear, sir? Is the point clear, sir? Hope this point is very clear. We will not discuss here because it is short crash course. Much this is, I think, more than sufficient what I have discussed. Right now, he's saying what are the dimensions of H parameters? H1 is ohms, H22 is mhos, H1 and H2 dimensionless quantities. So as the dimensions are not alike, That is, they are hybrid in nature. They are hybrid in nature. These parameters are called hybrid parameters. Hybrid parameters, right? Hybrid parameters. Now, what is saying, sir? For C configuration, for commutator configuration, they are represented with HIE. Sir, H11 is the input impedance. So for that, what I am trying to write, sir, this can also be write as HI. So what this is output admittance. So HO. So reverse HR, reverse voltage gain. What is this? Forward HF. So remember all this HI, H0, HR, the subscript. The first letter in the subscript is always represents the hybrid parameter. And what is second letter represents? Always the second letter represents. Always the second letter represents the type of configuration. It means, let's say HXY. I am saying. So X represents the parameter, hybrid parameter. Where is Y? Y represents. What is Y represents, sir? Y represents type of configuration. Very simple. It's going to be, let's say, HOC. So what does it mean by HOC, sir? HOC means this is output admittance. Remember, output admittance of C stands for collector. If it is E, it is emitter. If it is B, it is base. So output admittance of collector, output admittance of common collector configuration. This is how you will represent. So for a common emitter configuration, so HIE represents short circuit input impedance, open circuited output impedance. HR is open circuit reverse voltage transfer ratio, and forward current gain. HFE represents forward current gain. Okay. So this is the equivalent circuit which you have to replace. Sir. This HIE is input impedance. And the voltage source HRE into VC. HRE into VC. That is voltage. Output voltage VC. Now here you can write HRE into VC, right? It's going to be HFE into IE, and this would be 1 by HOE, 1 by HOE. That is, what is the HOE, sir? Output admittance. So if you want to calculate output resistance, it is a reciprocal of. In general, we'll add HOE, but generally it is a reciprocal of HOE. Okay. What is HFE? HFE is forward current gain. Forward current gain. What is HR? HR is reverse voltage gain. Reverse voltage gain. So we will not disturb this input voltage and sources and load resistance RL, sir. We will only just replace the transistor. Replace the transistor by its equivalent model. This is a transistor equivalent model, sir. If you know how we got this, if you know how we got this, you're very happy, sir. You'll be very happy. So once you know this equivalent circuit, you can play with anything. You can play with anything. So is the point clear? Is the point clear? So this is the equivalent model. The is the H parameter model of transistor. Transistor H parameter model. H parameter model. Very simple. Transistor H parameter model. Sir, if you see one problem, you will be able to understand how to do this. How to find out the equivalent model of a H parameter model of a transistor. So we will try to solve some problems so that you'll understand what I mean. But remember, this is a this must be replaced. So in case of normal PN junction diode, what happens, sir? We have replaced the transistor diode by its equivalent model or not? In piecewise linear model, ideal model, practical model, all these things are discussed or not? So similarly, here also we have some H parameter model. So similarly, we have some other models also. We have something called R-Pi model or RE model. That also we will discuss. Not worry, though it is a short term, I mean to say crash course, but still I'll try to discuss R-Pi and RE models also. At least I'll touch. But I don't do the lot of analysis of this H parameter model, where I directly will try to solve the problems so that you will understand it very clearly. Is the point clear? Is the point clear? Okay. Now you can see these are different configurations. You can see this is going to be common emitter, common collector, common base. So nothing will change. Nothing will change, right? So in common emitter, input current is IB, output current is IC. Nothing is changed. This input resistance is going to be what, sir? What is input resistance? Input resistance is going to be a HIE. This is going to be a HIE. If it is not visible, no, need not worry. I'm writing here. This will be HIE, right? So this is going to be HRE into VC, output voltage. HRE into VC, and it's going to be HFE into IB. You can see here. Input current is VB, output current is VC. Input voltage is VB, output voltage is VC. Now only this part of the transistor is replaced by its equivalent model. So we are not talking about those voltages or currents, resistances, everything. So I'm just trying to replace just transistor by its equivalent model, H parameter model, so that we can analyze the circuit very easily. This is the most important thing. Now, what is this common collector? In case of common collector, what is input current, sir? IB is input current. Output current is what? IE current, not IC current. IC current is still common to both input and output. IE current is going to be IE current is going to be the output current. The output current. So here VB is the base current VB is equal to HIC into IB plus HRC into VE. HRC into VE. For IE, it's going to be HFE into IB plus HOC into VE. So are you understanding or not, sir? Sir, very simple. If you can be able to understand one thing, you can solve any problem. You can solve any problem. So you need not worry. Do not worry. Only remember majorly common emitter. Common emitter. If you remember common emitter, so we can solve any problem because we will have a procedure to convert all these other H parameter models of common emitter and common base and common collector. We have a suitable method without remembering all these things. So we have simple methods where we can replace the transistor by its equivalent model. Transistor by its equivalent model, and we will other configurations also we can, if we know one configuration values, we can convert them into other configuration. Majorly he will be giving common emitter values, and he will be asked to convert them into common base or common collector. So we'll also try to express the parameters of common base and common collector in terms of common emitter. You need not worry. In the next slides only we will discuss that. You need not worry. So we'll move on. Now, so what is this then? Common base. For common base, what is the input current, sir? IC is the input current. IE is the input current. IE is the input current, and IC is going to be the output current. So IC is going to be output current. That is why you have HIB. You can say, I just now I told you this is going to be HIB. And what is the voltage, sir? What is going to be voltage, sir? Voltage is going to be now HRB into VC. HRB into VC. HRB into VC is going to be HFE into IE. HFE into IE. What is IE? Why is IE, sir? Input current. Input current. Here also HFC into IB because it is input current. This is input current. So this is a dependent resistance. This dependent voltage current source. This is dependent voltage source. This voltage source depends on the value of the output voltage, and this dependent current source depends on the input current. So this is on the output side. This is on the input side. So the voltage, the input voltage, that is depends on the output voltage. The output current depends on the input current. So see the relationship. So such a beautiful thing to remember and understand. So what is the value then? Here it is going to be VE. What is the input voltage? Input voltage and output current. Input voltage and output current. So input is emitter. So this is why I written VE. VE is equal to HIB. B stands for base into input current IE plus HRB into VC, output voltage. So then what is the output current IC? Output current IC is going to be HFB into IB plus HOB into VC. So these are the formulas. Which we used to remember, which needs to be remembered. And these are the ideal values, or the practical values of. So these are the practical values of H parameters. So what is HI, sir? HI is input impedance. HI is input impedance. Input impedance. And what is HR? Reverse. Tell me. Reverse voltage gain. Voltage transfer ratio or voltage transfer ratio. Voltage transfer ratio. And HF. What is HF? HF is not. What is that HF? HF is going to be forward current gain. Forward current gain. And what is H not? H not is output admittance. Output admittance is going to be output admittance. So as output admittance is not much useful. So because of that, now what we are trying to do, sir? We are trying to convert into resistances. Admittance is generally in ohms. This is no units, but it has ohms. I think is also mentioned here. So we are also trying to convert them into ohms. So kilo ohms, mega ohms. Now you can see here the input resistances, that is Hi is same for common collector and common emitter. It means, so can I say from this, can I say HIE is equal to HIC. HI is equal to HIC. Very easy or not? HI is equal to HIC. HI is equal to HIC. Remember this point. So just I'm trying to find relationship here itself, sir. So let's say he has given his common emitter H parameters. So he asked you to find out common collector. Common collector. Very simple. Very simple. HI is going to be HIC, HR. So HR is simply constant for HR is going to be 1 completely for common collector. I'll come back to common base later. But just first listen. Common emitter and common collector relationship. Common emitter and common collector relationship. Right? Then this is going to be HF. HF is going to be what, sir? Beta. Let's say beta. Beta I'm going to call is going to be HFE. HFE. Now what is this, sir? This, sir, is it not 1 minus HFE? I mean minus of 1 plus HFE. So this HFC is going to be what? HFC is going to HRC is equal to 1. So HIE is equal to HIC. Similarly, HFE now is going to be HFC is equal to minus of 1 plus HFE. So if you know CE values, you can easily calculate. These two values. Now you can also see H naught. H naught of E is same as H naught of C. So HOE is equal to HOC. Almost 3 parameters. HI, H naught, and then HF are almost same. Only HR is different. HR is for common collector is going to be 1. So we'll talk in the next class about what is this relationship between common base. Okay. So we'll try to wind up here. So remember again, the plus subscription is very important for the students who are seriously preparing for GATE examination. So what are the benefits of plus subscription is, you'll get access to the live classes. You can do the crash courses. Very importantly, and this weekly test is very important. So time and again I'm mentioning weekly tests are important. If and only if you do the weekly test, then only you will be able to solve the problems. Right. So again, you'll have something called doubt solving sessions. So every 4th hour is going to be a doubt solving session. And the sessions will be in English and Hindi. So you'll have a special batch called rank improvement batch. Those who are strong at foundation and those who want to increase their rank, they can use this plus subscription and write understand the rank improvement, join rank improvement batch. Now, apart from this plus subscription, we have another thing called iconic subscription. What do you mean by iconic subscription is, apart from this, along with this actually plus subscription, you have some benefits of, you'll have a personal coach, you'll have a study planner, you'll have a study booster sessions, you'll have a personal test analysis, which is very, very important. And you have something called preparatory study material. Preparatory study material will also be available. So what is the fee structure for a plus subscription, sir? For 12 months, you have 27,225 rupees. For 18 months, you have 34,650 rupees. For 24 months, you have 39,600 rupees. So for anything, you can use SVS10 as a code to get 10% discount. Sir, this is very cheap, sir. And for iconic subscription, for 12 months, your fees is going to be 45,225 rupees. For 24 months, you are going to have 66,600 rupees. And SVS10 is a code. To get 10% discount. You use this SVS10 as a code. Okay. So these notes will be posted in Unacademy GATE English Telegram channel, Unacademy English GATE Telegram channel. So I would request you to join this Telegram channel. I would request you to join this Telegram channel to get all the notes updates, right? So these are the different YouTube channels which Unacademy is having. So we have Unacademy GATE English, Unacademy Creatives GATE, Unacademy GATE Mechanical PI, that is PI stands for Production Engineering, XE stands for Engineering Sciences. So Unacademy GATE Civil and Chemical Engineering, Unacademy for Computer Science and IT, Information Technology, and Unacademy GATE Questions. Unacademy GATE Questions, special classes will be there on GATE Questions, and we will be having Electrical Junction. We will be having Electrical Junction. So these are different channels. And on Unacademy GATE English, these are the different faculty members who are taking the classes continuously for January month. So some of them are targeting 2021, some of them are targeting 2021, and some of the classes are already started for 2022 and 2023, sir. 2023, right? Okay, then I wish you all again a happy Pongal. Hope this Pongal brings a lot of happiness, prosperity into your life. So this year is very important for you, those who are writing the GATE examination, and at least those who are in second year and third year. For next year Pongal, you will be very much busy in writing the GATE examination. So please take care of yourself. Have a lot of fun, enjoy with your family, but the important festival will be once you get a gate, once you crack the gate. That is the most important festival for you. Remember that point. Okay. So thank you. So don't forget to like, share, subscribe, sir. Very important. Don't forget to subscribe this channel, sir. Please subscribe the channel. And hit the bell icon. So that you'll get all the updates. So thank you. Bye. Once again, happy Pongal. We'll catch up tomorrow.